Hello. In this video, I'm going to show you the flashcards that I have made for our short Unit 2. There are only 14 flashcards. It may be helpful for you to watch this, even if you're not going to make flashcards, but that's up to you. So these flashcards are not required. I just did them to give you guys a little bit of guidance on what I would use as flashcards if I were making them. So if this is helpful to you, awesome. And if not, then you're not required to watch this. So I'm going to show you my cards first. So I'm going to show you front and back. And then after I do that, I'm going to go through and talk about them a little bit. I want this video to be less than 20, as short as possible, definitely less than 20 minutes. So I might be going a little bit quickly. So yeah, use this as you think that you need and would be helpful. Okay, so first up is I'll show you my fronts and my backs. Okay, now I'm going to go through and talk to you about the flashcards. Just as a heads up, I used these as I went through and made the exam and did the exam. So each of these flashcards is, how do I say this? When you use flashcards, you should know everything on these flashcards before your test. Like, you should have them memorized and be ready to call this information up on your test quickly without having to sit and think for a while. These are all of the things, all of these flashcards that I've made, you see in the test. So I have not included any flashcards that that cover things from this unit, but you aren't going to see on the test. Everything you see on flashcards, you'll see on the test. That's why there are so few, because I only kept it to the things we absolutely need to know. So first one is facts about standard deviation. This was on our first standard deviation note page on the back side. So you only use standard deviation to describe spread when you have a data set that is not skewed and does not have outliers, because down here at the bottom it says standard deviation is not resistant to outliers. Standard deviation is like mean. When you calculate standard deviation, you have to use every single data value. So if you have a data value that is very large or very small, it is going to affect your standard deviation. One thing that I did not mention here that I probably should add in is that standard deviation measures spread or variance. So I'm just going to add that in. Standard deviation measures spread. Sometimes you will also hear standard deviation referred to as variance. So maybe I'll add that in as well. Sometimes standard deviation is referred to as variance. I don't like that very much, because if we look through our notes in the page where we actually learned how to calculate standard deviation, variance is a very specific thing. Variance is the sum of all of your squared deviations, but variance is also another word used for spread, so we might as well be aware that that could happen. So you only use it when you have symmetric data, because when you calculate standard deviation, you have to take into consideration every single data value. Standard deviation is always greater than 0, because if standard deviation is 0, that means that all of the values are the same. Because remember, the standard deviation is the average distance from the mean. So if there is no distance from the mean, that means every single number is the same. So here you can see, if this were my data set, my mean would be 5 and my standard deviation would be 0. And then lastly, standard deviation has units of measure. So if you're calculating standard deviation of heights, you put inches on the end. If you're calculating it of weight, you put pounds on the end. If you're calculating it of friends, you put friends on the end. So you must keep the units of measure that are in the problem for your standard deviation. You see that reflected in interpreting standard deviation. So I just gave the generic sentence frames for this, and anywhere that I have brackets is stuff that I'm going to fill in. If you need to have a concrete example of that, you will want to look in your notes or look to your practice test. Let me go grab that real quick. And I'm hoping that in this practice test, I gave you guys the opportunity to interpret standard deviation. So here on the Lakers player game, the weight of the Lakers player, that should probably have an S, typically varies by about 28.88 pounds from the mean of 222 pounds. So you do have an example of interpreting in your practice test. Next up is, please be aware that there is a difference between standard deviation and deviation, and you're going to see that reflected in this flashcard. So standard deviation measures the typical distance or the average distance of all of the values from the mean. Deviation is the distance of one observation from the mean. So standard deviation is what is the average distance of all observations. Deviation is when I give you a value and you tell me how far away from that is the mean. So why does that matter? Because when you get your question where it says you have a data set with a mean of 55 and a standard deviation of 7, what will happen to your mean and standard deviation if you add these points, you need to know the difference between standard deviation and deviation. So if you add 40 to this data set right here, your mean decreases because this number is less than the mean, and your standard deviation increases because 40 is 15 below 55. Well, 15 below is much farther away. It's twice as far than the standard, which is only 7. So the standard distance is 7. This point's distance is 15 below. So standard deviation is going to increase because it's farther away than the standard. If we add 60, our mean will increase because the point we added is bigger than the mean. Our deviation is going to decrease because it's only 5 away from the mean when the standard is 7. So it is less than the standard, so standard deviation decreases. And then lastly, what if you add a value that's exactly the mean? Well, X bar is going to stay the same. If you add the average value to the data set, then your average, your X bar, doesn't change. You got to be careful on your deviation though, because deviation now is 0. 55 is the mean, so there is no distance from the mean, which means that it is smaller than the standard. The standard is 7 away, but this has a deviation of 0, so that means your standard deviation decreases. It doesn't stay the same, it decreases because 0 is less than 7. If you're watching this, good on you, because you're probably going to see this on the test. Hint, hint. Z-score formula is very easy. Hopefully we all have that memorized. I just made sure that I went in and labeled all of the different elements. So this is our Z-score, or our standardized score. This is the given observation. This is the mean of the data that this observation comes from. This is the standard deviation of the data. Interpreting Z-score, make sure that you know this because it is on your exam, and because of that, I actually wrote in a specific problem. So this comes directly from your notes. Down here is the generic sentence frames. You have to memorize this. You have to memorize this. The AP board is very picky on how you interpret things. Memorize the card. Just memorize the darn thing, okay? Just gotta memorize it, okay? So if I have a Z-score of negative 0.48, what I would say is Mark's home run total is 0.4 standard deviations below the mean home run total for the MLB in 2001. So if you need help with interpreting Z-score, go to your Z-score notes and look that up because you will interpret Z-score on your exam. Finding standard deviation using the Z formula. So just remember, in the Z formula, you need these 4 things. You will be given everything but the standard deviation. These are just the steps to solve. Solving for X or finding X is very similar. You need these 4 things to use the formula. You don't have X, that's what you're finding. These are the steps to solve. The normal curve, I went through and labeled the empirical rule. You'll want to know that this is referred to as the empirical rule. In my sections of my normal curve, I have written down the specific percents. And then underneath, I have written down the empirical rule, 68, 95, 99.7. Be really careful that you know what are the values for each category, because on your quiz that you took, lots of people put the 95% lower bound and upper bound when they wanted the 99.7%. So make sure you feel really good about all this labeling. and that you'll remember it. Finding mu given a lower bound and an upper bound. Now on this one thing that I need to make really clear is that this formula here only works if the mu is in the middle of the max and the min that they give you, or it's in the middle of the lower bound and upper bound that they give you. So notice on these two examples that I have for you, the mean is in the middle. The mean is in the middle. This only works, this formula at the top only works if mu is in the middle of the numbers that they give you. So I have two examples, but one thing that I think that you should do now is figure out what sigma is for each of these. So pause and see if you can use this information to figure out sigma. Okay, sigma for the left-hand one is 28. Sigma for the right-hand one, I believe, is 6.5. I can calculate that very quickly, though. $6.5. Okay, you absolutely need to know how to find sigma using a lower bound and an upper bound. This is on your test. I have given you two examples where I show you how I figured it out. I have my different parts of my normal curve colored in because instead of thinking about it as the number of sigmas between your lower bound and upper bound, you can think about it as the number of sections. So like this one, your lower bound is 10 and your upper bound is 85. But in between those two lines I have drawn, there are 1, 2, 3, 4, 5 sections. Now that you have the standard deviation, see if you can figure out what the mean is, because you will have to do that on your test. Now that you know standard deviation, how do you use that to find mean? See if you can figure that out. So the mean for the left-hand one, I believe, is 46.5. I just took this lower bound and added the standard deviation until I got to the middle. Same with this one. If this is 10 and standard deviation is 15, then that means this is 25 and this is 40. Just to double check them, this would be 55, 70, 85. You will see this on your exam. Okay, we're getting close. We're about to hit that 20-minute mark. Know these symbols. So this is obvious, I think. Remember that if you ever draw a normal curve, you write down the parameters or the name of the normal curve. Instead of saying parameters, I always say you got to name it. I should really just say write your parameters down. Interpreting a percentile. This just comes directly from your notes. You do this in your practice test. And lastly, percentiles and the normal curve. You will need to use this on your test. So the most common percentiles are the 16th percentile, the 50th percentile, and the 84th percentile. So on a normal curve, the 16th percentile is at the -1 standard deviation. The 50th percentile is at mu, and the 84th percentile is at the first standard deviation. You need to know this and be okay working with it to answer one of the questions on your exam. So that's it for flashcards. I forgot to say this at the beginning, but I would do this first if you're planning to make them. Hopefully your practice test isn't done. If it is, great, good on you, good job. But if it's not, now I would use these to go in and see how helpful they are on your practice test. Okay, that's it. Hopefully that was helpful for you guys. Love you. See you soon.